Hello. In this section, we're moving on to a different conic section called the hyperbola. This one is definitely more complicated than the one in the previous section, but I think the more examples you do, the more you get the hang of it. So this picture down here, it kind of shows the basic shape of what these things look like. It kind of looks like two parabolas almost facing away from each other. So I'm trying to highlight the left one in red, for example. So there are two different types of hyperbolas. There's the, I guess I call these the horizontal types because the parabolas are opening horizontally, left and right. But the other type that we'll highlight in red now or I call it the vertical type, because the kind of parabola-looking pieces open vertically, upward and downward. So I'm going to call it that, and the way you can tell which one you're dealing with is by looking at the equation. So notice that for the horizontal type, the equation has the x fraction, the fraction that contains x first, and then a subtraction sign, and then the y equation, or the y fraction second. So the y term, or the y fraction, is negative, the x fraction is positive. Whereas with the vertical type, notice that the y fraction comes first, it's positive, and then there's a subtraction sign, and then the x fraction. So the x fraction is negative. And I guess a key component to these things and their graphs is that the pieces of these, or the branches they call them, of these hyperbolas, they obey asymptotes. So we've seen those before back in chapter 3 for the rational functions. When we learned how to graph those, there were vertical asymptotes, horizontal asymptotes, and then we found out that there were sometimes even slant asymptotes. These ones have more like slant asymptotes. They're going to have these diagonal lines that these branches obey. So these diagonal lines are what the branches of the hyperbola are going to get closer and closer to, but not touch. So it's going to be a key component to figuring out what their graphs look like exactly, is figuring out what these asymptotes are. So let's see, the asymptotes. Yeah, where are they located? Asymptotes. Well, I think we'll see it in a second, but they're located at y equals, this is the equation of the line that will become the asymptote. Y equals b over ax and y equals negative b over ax. So this first example doesn't ask about the asymptotes yet, but that's going to be coming up next. But let's see, the foci are yeah. Yeah, I think we're looking good. The foci, okay. So the vertices, we're going to look for the vertices of this thing and the foci, okay. In the first example, we have x squared over 25 minus y squared over 16. So if you think about it, which type is that? Is that the horizontal type or the vertical type based on its equation when we said which fraction comes first and which fraction is negative? Let's see, that would be the horizontal type, so I got to think about that. Horizontal, okay, so that means that it should have, let's see, horizontal type. It doesn't say that up at the top, but it should have vertices at the points A0, negative A0. So we just have to figure out what A is, and we'll know the vertices. The foci, those are a little more complicated. Foci should be located at A plus C, comma 0, and negative A minus C, comma 0. Vertices, oh, fudge. Sorry about that. There we go. What am I doing here? Okay, I'm sorry about that. I kind of messed that up. This should just, the foci don't involve A at all. I'm sorry. I think I was thinking of something else. They should just involve C, comma 0, negative C, comma 0, where C can be obtained using this equation here, where it's kind of small, so it's hard to see, but it shows it there beneath the picture. B squared equals C squared minus A squared. So that should be all the information we need here to find the vertices and the foci. So if I look at the equation I'm given here, x squared over 25 minus y squared over 16, a should be, like we saw before, the square root of the number below x, so 5, and b should be the square root of the number below y, so 4. So if I fill those into all my pieces of information, then I should have what I need. They ask for the vertices, which are always easier to find, vertices, and then the foci, those are always harder to find. A comma 0, well, a is just the value we found, 5, and then negative a comma 0 looks like negative 5, 0 is the other vertice. So that's where the two branches of the hyperbola are going to open up and open left and right. Okay, and then foci, we have to find those, but first we're going to figure out what c is by using this equation here. B squared equals c squared minus a squared. We'll fill in what we know. We know b and a. Let's see, b is, what did we say, 6? Oh no, sorry, 4. Hello. And c we don't know. We'll leave it as is. A is 5. All right, so this should tell us, once we solve this equation, that 16 equals c squared minus 25. Let me move that 25 over. That'd be 41 equals c squared. Okay, that means c must be the square root of 41, because c should be a positive number. And then my foci, like we said, are located at c comma 0, which means it looks like it's at square root of 41 comma 0, and then negative square root of 41 comma 0. So that's your exact answer, but I guess if you wanted to plot that point, you'd probably kind of think about that being a decimal. You know, what's the square root of 41? Put that in your calculator and then plot that point. That's probably easier. But they like us to keep exact answers, so I'm just going to leave it that way. And here's another one. This is actually another horizontal type, this example, because, again, this x term comes first, and then the y term. So it's going to have vertices, similarly, a comma 0, negative a comma 0. It looks like a, the square root of the number below x, should be 2. B, the square root of the number below y, should be 1. So our vertices should be 2 comma 0 and negative 2 comma 0. And as far as the foci go, let's see, foci, those should be at, like we said, c comma 0 and negative c comma 0. But we'll figure out what c is first. We'll fill in what we know. B is 1, c we don't know, a is 2, 1 equals c squared minus 4. All right, if we solve this equation, we should pretty much have the rest of the problem done. And move the 4 over, that makes 5. So c must be the square root of 5. All right, that means our foci are located at c comma 0, which is square root of 5 comma 0, and negative c comma 0, which is negative square root of 5 comma 0. All right, I think that's all they wanted, right? They said vertices, foci, yeah. All right, so I think now that we're kind of familiar with that piece of it, they're going to add a little more to these problems pretty soon. But now we're going to focus on a couple that are actually the vertical hyperbolas, which make it a little different. This is a vertical hyperbola, and that's because, like we said, the y term is positive, or y fraction, whatever. Positive, x negative. So it's kind of, yeah, similar. It'll be very similar. It's just the vertices are different. Before, with the horizontal type, the vertices were a comma 0 and negative a comma 0. Now it's 0 comma b and 0 comma negative b. So it's a little different, but it's got the same feel to it. In this case, let's see, my a should always be located below x, the square root of 16, so 4. And then b should always be located below y, square root of 25 is 5. So as far as vertices go, we don't really need to know a, but I just threw it in there because we'll need it to find c later. It looks like it's 0 comma 5, 0 comma negative 5. And then how about the foci? The good thing is we still use the same equation to find the foci value of c. B squared equals c squared minus a squared. I'll fill in what I know there. B is 5. C we don't know. A is 4. So it looks like 25 equals c squared minus 16. If I move that 16 over, what's that going to be? Didn't we already see this? 41 is c squared. What the hell? All right. Whatever. So c must be the square root of 41. I swear that we just saw that, right? But this time the foci are actually going to be 0 comma c and 0 comma negative c, whereas with the horizontal type they're at c comma 0. It's the coordinate where you put c is different now. It's in the y coordinate instead of the x coordinate. But otherwise it's very similar type of problem. And then we'll try this one. This is also a vertical type because the y term is positive and the x term is negative. So let's see, in this case, a, the value of a is below x, square root of 1 is 1, and the value of b is below y, the square root of 4 is 2. I think that should tell it to us. And our vertices should be at, like similarly to the last one we just did, 0, comma b and 0, comma negative b. B in this case was 2, so it'll be 0, 2, and 0, comma negative 2. Let's see, now our foci we need to find by using that same tried and true equation, b squared equals a squared minus c squared. Oh no, sorry, c squared minus a squared. I mixed them up. Sorry. B was what now? B was 2. We'll fill that in. C we don't know. A was 1. Let's see, that's 4 equals c squared minus 1. Why does this look familiar too? Move the 1 over. C squared is 5. That means c is the square root of 5. All right, and then again we said our foci are no longer, like with the horizontal type, they were c comma 0, negative c comma 0. Now the c is in the the y coordinate. So it'll be 0 comma c, 0 comma negative c, 0 comma square root of 5, and 0 comma negative square root of 5. All right, now that we have that down, I think we kind of know, it's kind of a pain to have to worry about vertical versus horizontal, and then the coordinates of the foci and the vertices are different. That's kind of a pain, but I think we kind of get the hang of it now. But now that we have that down, now I think we can kind of go the opposite way. What if they give us the standard form of they give us the foci and the vertices, and then we have to figure out what the equation looks like. So it's going to look like x squared over a squared minus y squared over b squared equals 1. If it's the vertical type, or y squared over b squared minus x squared over a squared equals 1. One of those types is going to be happening. But let's see, I think the key to tell which one it is they tell us that the vertices occur at 0, negative 3, and 0, 3. So that means that's going to be a vertical type. Remember we said for a horizontal type, the vertices should be like a comma 0 and negative a comma 0, because the non-zero value is in the y coordinate. That's how you know it's the vertical type. Non-zero value is in, the y coordinate. Okay, that's kind of what told it to me. Is that even a correct grammar? I don't know. But this is okay, so it's going to look more like this. At least I have a starting point. Y squared over b squared minus x squared over a squared equals 1. And we know by now that with equations like this, equations of functions, or just equations that we're supposed to graph, the y and the x are supposed to stay y and x, but we have to fill in b as, whatever the value of b is, and a. Once we do that, we're all done and this problem's finished. So the one thing that would tell me a piece of this puzzle is that since it's a vertical type, the vertices should be 0, comma negative b and 0, comma b. So I think I could just match up the y coordinates and say b is 3, just because of the vertices. Vertices. So we got b. I could fill that in if I wanted to. 3 goes there. Now the problem is a. So what other pieces of information did they give us? They said the foci are at 0, comma negative 5 and 0, comma 5. But the foci, if you think of it in general, the foci are supposed to look like 0, comma c and 0, comma negative c. So that means, if I just match up the values, c must be 5. So even though that's not what I wanted, because of the foci, c is 5. That's not what I wanted. I want to find a, but if I have b and c, I should be able to find a. So I'll use c equals 5 and b equals 3 to find a. Because we have that handy-dandy equation, b squared equals c squared minus a squared. In the previous problems that we just did, I knew b and a and I didn't know c. This time I know b and c, but I don't know a. Still, I should be able to figure out the one thing I don't know by filling those two in and solving for the last guy. Let's see, if I simplify that, 9 equals 25 minus a squared. If I move the 25 over, I think that's negative 16 equals negative a squared. If I divide both sides by negative 1, 16 is a squared. And if I square root both sides, a must be 4. So there we have it. Okay, so we have a is 4. And what did we say b was a long time ago? I already forgot. Oh, b was 3. All right, and that should tell it to us. Now we just need to fill it into our vertical hyperbola equation. It looks like this in general. I'm just going to fill in b with 3 and a with 4. There you go, and that's fine, but you probably see them actually square the 3 and make it 9, square the 4 and make it 16. But, you know, either way is a correct answer. So let's try this next one. I think this one's similar, except notice that the foci and the vertices have the non-zero number this time in the x-coordinate. That means it must be the horizontal type, because that's how their foci and vertices worked. So it must look like x squared over a squared minus y squared over b squared equals 1. And I just have to figure out a and b, kind of, you know, similarly to the previous one, and then I'm done. Vertices, though, remember for horizontal types, it should look like a comma 0, negative a comma 0. So just matching up the coordinates, a should be 6, just because these coordinates should be the same thing. So we have that, and then the foci should look like c comma 0 and negative c comma 0. So that means c must be 4 if I just match up those coordinates. The x coordinates should be the same, 4 must be c. So we know that a is 6 and c is 4. That means I should be able to use my equation b squared equals c squared minus a squared to figure out the very last value I don't know, b. So let's see, I'll fill it in. C we said was, which one? 4. And a is 6. Foci. You know what? I think I mixed these up. I'm sorry. Because, you know, if you picture this graph, okay, it's supposed to look like this. It's a horizontal type, and it says that the vertices are at negative 6, 0. So this is at negative 6, and this is at positive 6. But the way these things work, the foci are supposed to be kind of within the branches of the hyperbola. So this should be a foci, one of the foci, and this should be the other. But that means that the x-coordinates of the red points, the foci, should be larger, but they're actually smaller. So you know what? I think I mixed these up. I'm sorry. So if you don't mind, when you, on your notes, cross off the word foci, put vertices, and cross off the word vertices and put foci. I'm sorry, I screwed it up. So that means, well, that just means that kind of the c and the a values are opposite. This should be an a, so a is 4. And this should be negative c comma 0, c comma 0, so c is 6. That's all. So let me switch these. C is 6, a is 4. All right, now when I fill these in, that should make more sense. I'm sorry. I think I screwed this up. At least it was an easy fix once I kind of figured out what was going on. Let's see, 36 minus 16. So b squared is, that would be 20. B is the square root of 20. Or if you want to simplify that, that's 2 root 5, like we saw before. Because you could rewrite root 20 as root 4 times root 5. And root 4 is 2. There is no root 5. All right, I think now we're pretty much done if I fill those into my beautiful equation here. X squared over, what did we say a was? 6? No, 4. Yeah, a was 4. So 4 squared minus y squared over b was 2 root 5. Or you could just write root 20, because either way it's going to get squared right now. And I'll square that out. Let's see, 4 squared is 16. Down here you have 2 squared is 4 times square root of 5 squared is 5. So it should be a 20 under there. X squared over 16 minus y squared over 20. There he is. Not the best looking equation I ever saw, but hey, what are you going to do? All right, now, at this point, we're going to involve the asymptotes we were talking about. So we're going to graph and locate the foci. What are the equations of the asymptotes? Okay. That means we need a lot more information. The vertices. This is the horizontal type, so the vertices will be a comma 0, negative a comma 0. A is the square root of the number below x, so 6, and negative 6. So we know where the vertices are. They want to know where the foci are, so we'll look for that. That's supposed to be at c comma 0, negative c comma 0. Let's see, I think I can figure that out off to the side if I just use my little equation here. It should be that b squared equals c squared minus a squared. We already kind of figured out a was 6, but now we know b is 3 because it's the square root of the number below y. So if I fill those in, I should be good to go. 3 squared equals c squared minus 6 squared. That's 9 equals c squared minus 36. If I move 36 over, I believe that's 45. C squared is 45, that means c is the square root of 45. Or if you simplify it, 3 root 5. So that'd be your x-coordinate of the vertices. 3 root 5, 0, and then negative 3 root 5, 0. There they are. Foci. But the new thing we haven't talked about is asymptotes. Let's see. Asymptotes. They should be located at, first one, like we wrote in the very beginning of this section, y equals b over ax, and y equals negative b over ax. So let me fill in what I know. The b and the a. What was b again? B was 6. 6, and a was 3. All right, and that simplifies to, let me kind of section this off, y equals 2x. There's one asymptote. Similarly, the other one is y equals negative b, which is 6, over a, which is 3x. That means the simplified version should look like y equals negative 2x. And then you just graph those as if they're lines, right? They're asymptote, but you want to make dashed lines. So the y-intercepts are 0. So the first guy, the y-intercept is 0, the slope is 2. So I'll start at the origin and I'll go up 2 over 1. And that should be a good asymptote, that one there. The other one is similar, except you want negative 2 as your slope. So I'll still start at the origin. I'll make that my starting point. I'm going to rise negative 2, which is down, and run positive 1. Which will just kind of make it, it has basically the same slope, right? But it's sloped the opposite way, that's all. So there are my asymptotes. And then I need the vertices. What were the vertices again? Vertices, we found those in the very beginning, I think. 6, 0, negative 6, 0. 6, 0. All right, so 6, 0 starting there. There's supposed to be a branch, and I'm supposed to just kind of arch it closer and closer to the asymptote in both directions. So this is going to kind of be a really wide, or I guess really tall parabola. Same thing over here. So technically the green is the only part of my graph that really matters. The asymptotes were only there to kind of guide me along. And then where did we say the foci were? 3 root 5, 0, negative 3 root 5, 0. Let's see, 3 root 5, that's about somewhere between 12 and, let's see. Wait, no, sorry. Somewhere between 6 and, no. Well, I'm just going to say it's around here. Because the foci, you don't really need them to see what the graph looks like, but I guess they wanted us to identify them. This is negative 3 root 5, comma 0. That's one foci, and then the other guy was positive 3 root 5, comma 0. Somewhere around there. It's not a pretty number, but it's some decimal value. All right, let's try that again on this next one here. Okay. Graph and locate the foci. What are the equations of the asymptotes? All right. Well, we can mix it up if you want a little bit and actually find the asymptotes first. Y equals b over ax, y equals negative b over ax. In this case, the value of a is the square root of the number below x, so 3. And the value of b is the square root of the number below y, so 5. If I just kind of substitute those values in, I get an equation of y equals 5/3 x and y equals negative 5/3 x. So right away, before I do anything else, I can, if I want, plot those asymptotes. The y-intercepts are 0. I'm going to rise 5, run 3. Okay, that'll be the first asymptote, y equals 5/3 positive x. And the other one, I'm going to now rise negative 5, which is down 5, and then run positive 3, which will land me right here. And I'll just draw my nice diagonal lines. Okay, that's about right for the asymptotes. They want us to, now if I want to graph it, I need to find the vertices. Because this is a horizontal type again. Okay. The vertices are still going to be located like in the last one at A0, negative A0. So we said the value of A is 3, so 3, 0, negative 3, 0 looks like. All right, if I plot those, that should pretty much give me the graph 3, 0 is here. And then I'll just draw my branches closer and closer to the asymptotes as I go. Same thing at the other guy, negative 3, 0. There they are. I mean, that's basically the graph of the hyperbola. Oops, sorry. But they want the foci just... The foci aren't really important for the graph's sake, but they are important geometrically in other, I don't know, in other avenues that we're not familiar with yet. So I'll have to find the foci first, but I'm going to use my equation, of course. B squared equals C squared minus A squared. B was 5, and A was 3. 25 equals C squared minus 9. If I move the 9 over, 34 is C squared, which means C is the square root of 34, which is somewhere between 5 and 6. Yeah, and that's only I only know that because this 5 is the square root of 25, and 6 is the square root of 36. And this value, 34, is somewhere between 25 and 36. That's the only reason, I know that off the top of my head. But that means the foci are going to be located at, C comma 0, negative C comma 0. So square root of 34, comma 0, negative square root of 34, comma 0. And we said that's located somewhere between 5 and 6. So somewhere around here maybe is one foci, and the other guy's at the negative value, somewhere between 5 and 6. There, that looks good. Okay, now let's try these ones. These ones are a little weird because they're not in the right form. This guy doesn't quite look right, but he should be in this form, y squared over b squared minus x squared over a squared. And I'm only writing y first and then x because that's how they have it, just thinking that's how it should look. And now, I guess the difference is, notice that there should be a 1 on the right side of the equation. This is not a 1, but it should be. So I think that I need to do something to manipulate this before I do anything on this problem. This needs to be a 1. That's the problem here. It needs to be a 1, which means I could, if I want, I could divide the whole thing by 4. That would make that, that value a 1. But of course that'll affect all the other terms. That's y squared over 4 minus... Here the 4's cancels on the x term, so it'll be just x over 1 if you want something down there, and then equals 1. So now this is a vertical type, and I can go about my business the same way. The vertices now, because it's a vertical type, should be 0, comma b, 0, comma negative b. The b value is the square root of the guy below y, which is 2. The a value is the square root of the guy below x, which is 1. So my vertices should be 0, 2, 0, negative 2. And then asymptotes are always the same no matter which type you have. Should be y equals b over ax, y equals negative b over ax. So y equals, let's see, b is 2, a is 1. So yeah, very similar, actually the exact same asymptotes as the first problem we did. Negative 2 over 1x, which means y equals negative 2x. So we got asymptotes, we got vertices. Now foci is the last thing. Should be at, since this is the vertical type, it should be 0c, which is 0, comma something, and then 0, comma negative c, which is 0, comma negative something. But to figure out what c is, I need to substitute those a and b values into my favorite equation. B squared equals c squared minus a squared. B was 2, c we don't know, a was 1. So 4 equals c squared minus 1. If I move the 1 over, 5 equals c squared. So c is the square root of 5. There it is. So looks like it's going to be 0, comma square root of 5, 0, comma negative square root of 5. Then I'll just fill all that information in. The asymptotes are y equals 2x, which we've seen before. This guy, if you don't, use the exact same slope and y-intercept as the very first graphing problem we did in this section, and y equals negative 2x, which looks like that. And then we said, so this thing's going to open upward and downward because this is a vertical one. The vertices are 0, 2, 0, comma negative 2. So around here somewhere, and then it opens up and gets closer and closer to the asymptotes, excuse me, and then 0, comma negative 2, which is down here. And that'll open up and get closer to the asymptotes. And the foci are at 0, comma root 5. Root 5 is a little bit bigger than 2, but somewhere smaller than 3. So the foci are really close to the vertices. I probably can't see it because I would really need to zoom in, but that's supposed to be a foci. Foci. So it's all the information is kind of packed tight in that problem. Yeah, interesting. How about this one? This one's similar. We need this to be a 1, just like in the last problem, because this isn't really given to us in the right form. They're kind of messing with us, but the quick fix is I'm going to divide every term by 225. 225. Let's see, does 9 go into 225? Don't judge me if I use a calculator, okay? I think it should. A lot of times these end up being really pretty. Let's see, 225 divided by 9 is 25, okay. It looks like this reduces to leave y squared over 25. And then 25 goes into 225 9 times. And here 225 over 225, of course, is 1. Now I think we're ready to go for this problem. You can find vertices, foci, asymptotes in any order you want. But let's see, vertices are supposed to be, since this is a vertical type, it's supposed to be at 0, b, 0, negative b. B in this case is the square root of the number below y, so 5. A is the square root of the number below x, so 3. So my vertices should be at 0, 5, 0, negative 5. And then my asymptotes, like we said, they're always the same no matter which type you're talking about. It should be y equals b over ax, y equals negative b over ax. B was 5, oops, A was 3, so y equals 5/3 x. Similarly here, but a negative. So we got vertices, we got asymptotes, foci is the last thing, and then we're pretty much ready to finish this problem. Foci, but like we've seen a million times by now, we need to figure out what C is before we figure out the foci. B was 5, A was 3, 25 equals C squared minus 9. Let's see, if I move the 9 over, it'll be 34, I believe. So C must be the square root of 34, which is between 5 and 6, again. All right, so the foci are supposed to be at 0, C, which would be 0, square root of 34, and 0, negative C, which is 0, negative square root of 34. So let me plot all those things. Let's see, the vertices were at 0, 35, 0, 5, so right here, and 0, negative 5, so right there. And the asymptotes were y equals 5/3 x. That means I start at the origin and I rise 5, run 3, somewhere around there, excuse me. And then y equals negative 5/3 x, which means I rise down 5 and run 3 this time. And he looks something like that, negative 5/3 x. And then from there, I don't really need the foci to plot the branches. I'm just going to start at the vertices and get closer and closer to the asymptotes as I go. But the foci, as I said, should be located somewhere between 5 and 6. So they're really close to the, what's it called? The vertices here, foci. Well, I guess technically the singular of foci is focus, so I should say. This is one focus, this is another focus. Yeah, okay. Looks good. And now what are we looking at here? So these are probably the tougher ones, because the ones we're going to tackle now are they're hyperbolas that are not centered at the origin, which they're too complicated for me to ask you about on a test, on an exam or midterm, you know. So don't worry about these too much. You will see these again in a future class, so, or you should, I don't know. Maybe it depends on the class you take, I don't know. But the things go a little differently. Notice that all the problems we've done so far, they were centered at the origin. So the two branches of the hyperbola kind of opened up from the origin outward, from left and right or up and down. But these ones they're gonna have a different center. So center should always be h, k. Where kind of like we've seen with other types of equations, h and k come from the numbers that are inside parentheses with x and y. So h is 3 in this case, and k is 1. And you do have to change both signs. I see that the 3 is negative in those parentheses, but I change it to positive Same thing with the 1. So now our center is 3, 1. That's going to be where everything starts. And then from there, I'll see all my asymptotes. Let's see, so the asymptotes, as it says, it kind of describes up there, they can be found by placing, excuse me, one point at the center of the hyperbola and another point, okay, b units right, go b, which is 1 in this case, because that's the square root of the number below y, and then a is the square root of the number below x, 2 units down, and that's from the center. So where's that center? There he is, that red dot. I'm going to try to use a different color just so I don't confuse myself. From there, I'm going to go 1 unit right and 2 units down, which would land me right here. So that'll be 1 value. Oh wait, did I do that right? Oh wait, what the hell? B units, right? Sorry, I screwed that up. I'm not even listening to my own directions here. Oh my gosh. Oh Lord. Let me erase that. I'm sorry. That guy was screwed up. I think there's 2 different steps there, 1 and 2 up there above in this, let's see, in this box. I was trying to do both at the same time, but it's 1 and then the other. Hella. So I'm going to go first up B units. B we said was 1. And right A units, which A was 2 we said. Alright, then I'll put a point there. The other one I'm supposed to go down B units, down 1 unit, and right A units, which is 2. Oh, sorry. Alright, I'm going to try that. Let's try that. So from the first guy, up 1 unit from the center. If I go up 1 unit and then right 2 units, that's going to land me right here. And then you really just connect those 2 dots, your center and your point you just drew, and that's 1 asymptote. The other one, I start at the center and I go down 1 unit and right 2 units. So down 1 unit, right 2 units, that would land me just below the other point I just drew. And then that asymptote should go through. So your asymptote should always go through the center. And that's actually what's been happening this whole time with even the ones we've been doing before, where they're not centered off to the side, they're centered at the origin. Yeah, that's still been going on. So but kind of more complicated here for sure. And that's definitely why I wouldn't test you on these ones. This is complicated stuff that, we'll worry about that in the future, in a future class. Let's see here. Now, what else do they want us to do? No. Graph it. Where are the foci? What are the equations of the asymptotes? Okay. Let's see here. I need to figure out where the vertices are. We haven't talked about that yet. But the vertices, in this one, since it's a horizontal type, the vertices should be located at, it's kind of like, okay, you start at h comma k, the center, h comma k, but you have to go left and right a certain amount to get to the vertices. So I'm going to go right a amount and then left a amount. Those will be your the vertices, because everything kind of starts at the center, h comma k, and then you're moving left or right or up or down depending if you have horizontal type or vertical type. So the value of h, would we say it was 3 plus our value of a, here I'm going to actually write it out, a was 2, b was 1. So h plus a, h was 3, a was 1, comma k was 1. So looks like the point is 4, 1. That's where my first vertex is. The other one is h, which is 3 minus 1, which is a, comma k, which is 1. So at 2, 1. Let me plot those 2 points. 4, 1 should be right here, kind of right in the middle of that, the 2 asymptotes. And the other point is 2, 1, which should be here. So notice that everything's kind of symmetric about the center, which is a good sign. And then I'll draw my branches from there. There we go, beautiful. Beautiful, all right. And this time the foci, not that I need them for the graph, but again, they want them, should be located a similar way to the vertex, except instead of being h plus a, comma c, it's h plus k, comma c, comma k, and then the other guy is h minus c, comma k. So notice if you kind of erase the h and the k, it looks a lot like the foci for the previous problems we did. It's just c, comma 0, negative c, comma 0. But I guess it's like instead of starting at the origin 0, 0, we're starting at HK, so we have to involve those in the foci as well. But I have to figure out what the value of C is. Let's see, B squared is C squared minus A squared still. At this point, I already forgot what B and A were. B was 1, A was 2. I got 1 squared equals C squared minus 2 squared. That's 1 equals C squared minus 4. C squared is 5. So in other words, C is the square root of 5. All right, and if I fill those in, I should have the problem finished. C is the square root of 5. Minus, but I forgot already what H and K were. I just had it, and I totally forgot. H was 3 and K was 1. All right. H was 3, let's see, 3, K was 1, 3, 1. Those aren't pretty foci, but hey, that's what they want, that's what they get. Those are the exact answers. So let's try this other one, and I think we're good to go here. So this one, the center, again, it should be H comma K. But this one's kind of tricky because H is located with X, so he's actually second. And K is located with Y, so he's actually shown first. And I'm changing both signs. Remember, X had a negative 1 next to him, but I'm changing it to positive 1. Y had a had a positive 2 next to him. I'm changing it to negative 2. So yeah, that looks good. All right. Center's there. Let me see. If I want just to kind of get ready for what's going on, I'm going to plot that center. 1 comma negative 2. 1, negative 2 is down here. Okay, so everything's going to be centered around that. All right, then we'll find the asymptotes kind of like described in that box over there. Asymptotes. I'm going to go, first thing it says is I'm going to go up B units and right A units. So I'm going to go up B, which is 2 in this case, the square root of the number below Y, and right A units, which is the square root of the number below X, so 4, square root of 16, 4 units. If I plot that point, that should give me an asymptote. Let's see, up 2, right 4. So from that center, up 2, which will land me on the x-axis, right 4, which will land me here. And I'll just draw my nice dashed line right through that center and right through the second point I just drew. There's one asymptote. And the other one is similar, except we're going to, as it says here, go down B units this time and right A units. So down B equals 2 units, but we're still going right A equals 4 units. A equals, let's see where that lands us. Down 2, right 4, from the center. So from that blue point, I'm going to go down 2, right 4. That'll land me right about here. And I'll draw my nice diagonal line right through that. But this time, now we're going to look for the vertices. But since this is clearly a vertical hyperbola, vertical type, because the y term comes first and the x term comes second, that means the vertices might look a little different. Still though, because this is not centered at the origin, our vertices are going to start out with the h comma k. But since this is a vertical type, the vertex should be above and below the asymptotes. So it's going to mean that I'm adding something to the k value or the y value, and then subtracting something from the k value or y value. So remember with the regular horizontal types before, they look like 0 comma b, 0 comma negative b. It's just more like, what if I add a h and a k in the x and y coordinates respectively, then it would look something like what we just wrote down here. You know, if that makes any sense, hopefully. H is 1, k was negative 2, and b was what now? 2. So it looks like one vertex is right at 1, 0, if I fill everything in correctly. And then the other guy, 1 comma k, which is negative 2 minus b, which is 2. So this time it's 1, negative 4. So let me draw those points. 1, 0, 1, negative 4. 1, 0 would be right here, and then 1, negative 4 would be around here. That's a good sign that those are equidistant from the center. Everything should be kind of, such equidistant from the center. So I'm just going to draw my branches of my parabola, getting closer and closer to those asymptotes. And this is a really wide hyperbola here. But whatever, it looks good. And that's fine as far as the graph goes, but it sounds like they want the foci, even though like I said, we don't really need them to find the graph. Alright, this time the foci are also a little different. They're very similar to the vertices. It's going to be h comma k plus, but in this case c, and h comma k minus c, instead of the b value. But of course, like we've seen a million times, I have to go find out what c is first. B squared equals c squared minus a squared. And I definitely forgot what a and b were already. B was 2 and a was 4. 2 goes here, 4 goes here. Okay. So if I simplify that, 4 equals c squared minus 16. If I move the 16 over, I'm kind of running out of room here. 20 equals c squared. So c must be the square root of 20, or if I simplify that, that's 2 root 5. There we go. So I can fill everything I know in now, and that should be my foci. So h, what was h again? Oh lord, I already forgot. 1, and k was negative 2. But now to the y coordinate, or to k, I'm adding the value of c, so 2 root 5, and then I'm subtracting for the other foci. There they are. That's the exact answer, and like I said, if you wanted to plot those points, you would just kind of plug that value into your calculator and see what that is. I don't know if you're curious. I'm kind of curious now. I'm going to plug that in my calculator. It's negative 2 plus 2 root 5. This guy's about 2.5 if you round it. And this guy, if I put this one in, negative 2 minus 2 root 5. It's about negative 6.5 or so. Something like that. If you round it, it's not going to be exact. So if you're interested, I'm going to plot those points. 1, 2.5. Where is that? That's about here. And the other guy's 1, negative 6.5. So he's about there. That looks about right, I guess. Those foci are above and below the center and within the branches of the hyperbola, which they should be. And they look equidistant from the center, so that's a good sign. Oh, that is a very tough section, so I'm sorry that you had to endure that, but if you got through it unscathed, you're doing pretty good.